Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on July 24, 2025, so about 2 weeks ago. This paper introduces a framework called efficient agents that achieves 96.7% of the performance of a leading agent, while improving the cost of pass by 28.4%. Now, cost of pass is a key metric here. It's the cost of a single run divided by the success rate, really measuring the bang for your buck. The paper is titled, Efficient Agents, Building Effective Agents While Reducing Cost, and the implications for building sustainable AI are pretty significant. The authors provide a deep, systematic analysis of the trade-offs involved in designing these complex systems. Also, the authors shared their official implementation on GitHub. If you check it out, you'll find the complete OAgents framework. It has everything you need to get started, including setup instructions and the scripts to reproduce their experiments on the GAIA benchmark. Alright, so this first figure gives a fantastic overview of all the different components the researchers tweaked to find that efficiency sweet spot. They looked at everything, from the core LLM backbone itself, to how the agent plans its steps, what kind of memory it uses, and what tools it has for things like web searches. They also experimented with test time scaling, like a technique called best-of-n sampling, which is basically running the model multiple times to find the best answer. All this analysis led to their final efficient agent design. Building on that idea of testing different LLM backbones, this chart really brings that trade-off to life. It plots accuracy on the vertical axis against cost on the horizontal axis. So the ideal spot is that top left corner. You can see models like Claude 3.7 Sonnet and o1 are up here in the top right. Very high accuracy, but also the most expensive. Then down here in the bottom left, you have these much cheaper models like the Quen series, but with lower accuracy. And GPT 4.1 lands in a really interesting middle ground. This table then gives us the detailed numbers behind that plot. For example, you can see Claude 3.7 Sonnet gets the highest accuracy at 61.82%, but its cost of pass is 3.54. In contrast, GPT 4.1 has a much lower cost of pass at 0.98. What's also really interesting is how this changes with task difficulty. For Claude, the cost of pass jumps from 1.69 on level 1 tasks all the way to 9.04 on level 3. So taking all those component analyses into account, this final table shows how their new efficient agent stacks up against other popular open source agents. And the results are really impressive. Their efficient agent achieves a cost of pass of 0.55, which is a big improvement over OWL's 0.75. At the same time, its accuracy is 51.52%, which is very close to OWL's 53.33%. This means they significantly cut costs while keeping performance nearly the same. And this table here lays out the exact recipe for the efficient agent, the specific configuration that achieved those great results. Based on all their experiments, they landed on using GPT 4.1 as the backbone, with a maximum of 8 steps for planning. They also use a multi-source search, but keep best-of-n sampling at just 1. And for memory, they chose that surprisingly effective simple option. It's this precise combination of components that delivers that impressive balance of high performance and low cost. So in the end, it's all about making smart, deliberate design choices. This work clearly shows you can build powerful AI agents that are also sustainable and accessible, not by just chasing the biggest, most expensive models. That's it for this episode of the